Okay, in this video we are going to look at the components of a muscle fiber. Okay, when we look at muscle cells are also known as a muscle fiber. Let's identify some of the components of this. We know from looking at different things in the past that a cell has a plasma membrane and it has various organelles located within it. So intracellular, there's various organelles. Some of those organelles are the mitochondria. There is the endoplasmic reticulum, rough or smooth. There's the Golgi apparatus, and there's other structures along that line. There's also cytoplasm within a cell, and then you have a nucleus as part of a cell. Now, muscle fibers also have those structures, but we're going to start to name them differently. Okay, so let's first address some of this and look at this screen that we have on here. And the first thing that we want to change the name of is the plasma membrane. So plasma membrane equals sarcolemma. Okay, so when you hear me say sarcolemma, think plasma membrane. There's some subtle differences between a regular cell membrane and a muscle fiber membrane, but we are going to call that a sarcolemma. And let me just point that out on the picture right now. A sarcolemma is going to be that structure. So it's just kind of peeled away so you can see it, but that is the plasma membrane for this one. The other thing that I want to change the name of is the cytoplasm. So let me do, I kind of drew a line over that. So let me do cytoplasm. And the new name we give that is sarcoplasm. Sarcoplasm. So instead of cytoplasm, we now have sarcoplasm. And the last thing that we are going to change is smooth ER. If you recall what that means, that's smooth endoplasmic reticulum. We're going to change the name from smooth ER, or it's very similar to smooth ER. We're going to change the name to sarcoplasmic reticulum. So here, so we do so sarcoplasmic reticulum. And in this picture where we see those, that's going to be that mesh looking thing. Okay, so if we go down here, that's that. Okay, I'll probably erase those. As a matter of fact, let me erase those two areas because I want to draw through that area as well. So let's do, if I can delete that, there we go. I think I went too far, so that's a LUM. Okay, so that's what we're looking at, and I'll discuss what the differences are here in a second. So the muscle fiber, the plasma membrane for the muscle fiber is sarcolemma, the cytoplasm is sarcoplasm, and the smooth ER is like the sarcoplasmic reticulum. So let's go through the different components. The first thing I want to point out with skeletal muscle cells are multinucleated. By that I mean the skeletal muscle has multiple nuclei. The reason it has multiple nuclei is during the development stage, you have stem cells called myoblasts. So let me go here. So let me just do here. So myoblast fuse together to form skeletal muscle. Okay, so each one of the muscle or the myoblast has a nucleus. So if you have multiple myoblasts fusing together, now you have multi-nuclei forming this, okay? So let me just do a really brief, where is this here? Let me just do a real, I'll come back to that picture in a second. A really brief view of a skeletal muscle. Okay, so this would be skeletal muscle. Let me do the nuclei in red. So this would be a nucleus. That would be a nucleus. This would be a nucleus. Looks like we'd have one here and a nucleus there. Okay. So this is multi-nucleated. And one of the things that we're going to talk about is that skeletal muscle fibers are striated. When you look at the muscle fiber underneath a microscope, you can see light and dark lines. And real briefly, oh, that's really bad. You'll see lines. I'm just doing this really quick through there. You'll see lines like this, and those are called striations. Therefore, that muscle is striated. Okay, so that's really briefly a quick overview of the multinucleated portions. Now, the myoblasts that don't fuse in the embryonic stage, those that don't fuse together, become satellite cells, and then satellite cells can aid in repairing any skeletal muscle tissue that has been damaged. Okay, so multiple myoblasts fuse together to form skeletal muscle, and therefore you have it multinucleated. And those myoblasts that don't fuse early on differentiate into a satellite cell, and then satellite cell can help in the repair of any damaged tissue. All right, let's go back to that one picture and look at the different components of here. Now, what we're seeing, let me go back to black on this. Okay, what we're seeing that the sarcolemma encases everything on the inside, and you can see all these various structures here. We got a bunch of these different structures, okay, and we extended one a little bit further out, okay, and each one of those structures are called a myofibril. Well, that's really bad. Let me erase that one. Okay, so inside the muscle fiber, you have a lot of myofibrils. Okay, in fact, 80% of the muscle is filled with myofibrils. So what are myofibrils? Myofibrils, if we're going to come down here and look at this bottom picture here, myofibrils are made up of bundles of myofilaments. Okay, so a bundle of myofilaments make a myofibril. Okay, just remember that. A bunch of myofilaments make up a myofibril. You put a bunch of myofibrils together, wrap it with a sarcolemma, now you have a muscle fiber. Okay, so what makes up myofilaments? Myofilaments are made up of actin and myosin. And I think I'm going to do this on a third video. I'll just make an executive decision right now. I'm going to do a third video focusing specifically on the actin and myosin. So this is just your intro to this one, okay? So let's look at the beginning. You have a bunch of actin and myosin myofilaments bunched together forms a myofibril, okay? A bunch of myofibrils are contained within the muscle fiber. The muscle fiber has the plasma membrane called a sarcolemma. And then we go on into that previous video where we're having a bunch of muscle fibers, gives you the fascicles, you know, wrapped with endomysium, paramysium, and so forth. That's the previous video, okay? So let's look at the other thing that I was pointing out here, which is the sarcoplasmic reticulum. You can see that's the purple mesh that we're looking at down here. That's the sarcoplasmic reticulum, which I'll just abbreviate SR. Okay, SR. That's the mesh. And the sarcoplasmic reticulum contains calcium or calcium ions. All right. Now here's where we're walking the line between anatomy and physiology. So I'll dabble a little into the physiology so it helps you understand what the anatomy is doing. Though next semester when you get into the physiology component, you'll get into this in much more detail on this one. Okay? So when we go back here and we look at the sarcolemma, now let's put all this stuff back together. So let's look at the sarcolemma. I tell you what, let me erase some of this stuff. It's on video, so you can always go back and look at this stuff. So let me erase this. And let me get rid of this. Let me get rid of this. And let me get rid of all this down here. What the heck? Let's just get rid of that as well. Okay, so here's where we're at. We're starting out at the beginning again. So we have our sarcolemma. I left that one on so you know that this is the sarcolemma. Okay, let me just draw that back down here. Okay. Now you will notice that the sarcolemma has these little black dots. Okay. Those little dots are actually, well, kind of holes. Okay. They're deep invaginations of the plasma membrane that penetrates deeper into the muscle. What does that mean? So let's do a kind of a cross section on, where's my cursor? Let's just do a cross section of what actually this looks like. So if this is your plasma membrane, okay, so we're just looking at it from the side. So we're over here looking at it this way. And we come up to one of these little holes and it's a deep invagination, meaning it just goes down like this, comes back up, and it comes back on. And then it comes down again, and it comes back up. So those are the deep invaginations. And what those holes are called, they're called T-tubules. So let me tell you what, let me go down here so we can see this. T-tubule. The T stands for transverse, okay? Those are transverse tubules or T-tubules. Another thing that I want to point out, and I'll put all this back together here in a little bit. Another thing that we have, and let me change the color so we can see this a little bit better. Let me use green, okay? What we have here is we have something that runs parallel to the T-tubule. And let me just start drawing these things, okay? It's a really bad representation, I know, but this, I actually should have done them in purple, okay? So let me go this way. That's that stuff. And you can see this purple line. I tell you what, let me back that up. Let me definitely. Okay, so one of the things that we will see on here, on the sarcolemma, we have those little tiny dots. If you can see these little tiny dots, all these little different things here, those little tiny dots are called T-tubules. And the T stands for transverse. So those are those little tiny holes. Okay, so let me put holes. Okay. The T stands for transverse. And what those do is they're just not a hole in the membrane. They're deep invaginations of the membrane. And it allows for the plasma membrane to penetrate deeper into the muscle fiber. So let's kind of draw a kind of a cross section here. So this would be the plasma membrane, and then I'm going to come up to a T-tubule, which is that hole. Ooh, this hole, so much for doing this straight. Okay, so this is the sarcolemma, and then this is the T-tubule. Okay, that makes a little bit more sense like this. The next thing that we are going to discuss on this are something that's called terminal cisternae. All right, so terminal cisternae are, let me go with purple on here to try to be consistent with the picture on here. Okay, terminal cisternae are tubes. Okay, a blind end tube, so it doesn't go anywhere on this side, that parallel each T-tubule, just like this, okay? And this is just a tube that stores calcium ions, so it's a calcium ion reserve. These T-tubules connect to this this webbing looking thing, okay? So kind of come around here, looks like that, okay? Those are the sarcoplasmic reticulum, okay? So this is the T-tubule. This is the T-tubule. This structure, okay, not this part, but just the vertical portion. This part is called the terminal cisternae. So let me make sure I spell this one correctly. Terminal. I should know how to spell terminal. Terminal cisternae. C-I-S-T-E-R-N-A-E. C-I-S-T-E-R-N-A-E. Terminal cisternae. Okay. So when we have the terminal cisternae, let me go to a different color so we do this. So we have one here. We have a T-tubule. We have one here. And then we have another terminal cisternae. Together, that forms a structure called a triad. So the three of these form a triad. Okay, triad for three. Okay. What else did I want to do? One more thing on the plasma membrane. Let me go down here. Okay, so let me draw the plasma membrane, and we're going to briefly talk about gates. Okay. So this is a very close-up view of a plasma membrane. This is extracellular. Or outside of the cell, and intracellular, which is on the inside of the cell, okay? Now let's take a moment and talk about gates. All of our plasma membrane have gates on them. And when you think of a gate, think of a gate at your house, okay? So you've got a fenced-in yard. Well, that fence has a gate on it. When that gate is closed, it prevents things from getting in to the yard or out from the yard, okay? You can have different sizes of gates. Now, when you look at the gates of a plasma membrane, these gates are specific to certain things. So again, let's go back to our house example here. And we have kind of a doggy gate, okay? So put like a little doggy door in a door. Well, that's essentially a gate. and it allows the dog to go in and out. It doesn't allow me to go in and out because I'm too big. It doesn't allow a car to go in and out because the car's too big without causing other damage, okay? Well, the gates in our plasma membrane are also specific to certain structures. So you're going to have gates that's specific to sodium ions, and therefore it only allows sodium to enter or exit. You have gates for calcium, you have gates for potassium, and again, those gates are specific to those ions as well. Now, those gates are necessary to allow this electrical charge to propagate over the plasma membrane. Now, we'll get into this more in lecture, but let's just say we have a few different gates. Let me make the gates in yellow, okay? So we have a gate here. Let me erase a little bit of one of these gates. Okay, and let me do another gate here. But this is going to be, I'll do another gate. Let me go to pens. Okay, now I'm not going to be too specific on this, but when a gate is closed, again, it doesn't allow something to enter or exit the cell. But when we have this gate, the charge, well, let me do this in red. We have a charge on the outside of the cell, and we have a charge on the inside of the cell, okay? When this charge moves along, these gates open and close, and it allows some of this charge to go in, all right? What this is doing is this is allowing the electrical charge to move across the sarcolemma. Okay, so this is allowing, because remember one of the characteristics of muscle is it's conductive. Okay, this allows the electrical charge to propagate over the cell membrane. Now let's add in really quick that T-tubule. So this is the T-tubule. Kind of really bad view of this, okay? But we also have gates down here, okay? We're going to have gates both sides, okay? So when this charge, we're doing the charge in red, so when this charge moves in this direction, it's going to go down the T-tubule, okay? And this charge opens up another gate, okay? In other words, those are voltage-gated channels. These gates are also known as channels, okay? Voltage-gated means when we change the voltage, that gate will either open or close. And if it's voltage-gated, this charge that comes down over here, it will open up one of these gates and it allows stuff to move in. Okay, just grasp the basics of this. It's going to get into much more detail as we go through, okay? Now remember, we also had our terminal cisternae. So here we have a terminal cisternae. This is a tube. And do you recall what's in that tube? It's a reservoir for something. If you can think of that. That's going to be calcium ions. Okay. So calcium ions are stored in here. So when we have this charge that comes down through here, it opens up this gate, which opens up a gate on the terminal cisternae, which allows the calcium to go into the sarcoplasm. All right. This is really confusing. I understand. So let's put this all together one more time. Nice and slow. And the next video we'll look at the specific myofilaments, the actin and myosin. Okay. So first of all, sarcolemma is your plasma membrane. Sarcoplasm is the cytoplasm. Sarcoplasmic reticulum is similar to the smooth endoplasmic reticulum. Okay. The plasma membrane has channels. Okay, these gates. Okay, so these are channels. Okay, and those channels, when they open and close, allow certain chemical ions to either enter or leave the cell. And when those charges move along the sarcolemma, it allows for propagation of that electrical charge. Okay, pause right there, go through that a couple times until you get that part understood. When we follow that charge across the sarcolemma, it then goes into the T-tubule, which is a deep invagination of the sarcolemma. And when it penetrates down, that charge then makes its way to the terminal cisternae, the purple structure here. When that charge reaches the terminal cisternae, it opens up channels and allows calcium to enter the sarcoplasm. Okay? Let's see, what else did we want to do? Multiple myofilaments make a myofibril. Multiple myofibrils are stuffed into a cell, muscle fiber, and it makes a muscle fiber. A muscle fiber is wrapped with endomysium, okay? And it makes multiple muscle fibers make up a fascicle. Fascicles are wrapped in paramycium. Multiple fascicles grouped together makes the named muscle. You wrap the named muscle with epimysium. Okay, so you can see how that pattern is going. Okay, I know this one's very confusing. We'll cover it in much more detail in lecture. Watch this a few times, get a general understanding of this, read along in your textbook, and we'll go from this one. So the next video, we're going to look at the actin and myosin filaments. And then we'll start putting some of this stuff back together. Good luck.